Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to decide what we are going to do with our JSFX library, this library that is going to help you write better looking, easier to develop JSFX, which are real-time audio processors in REAPER. And what we did last time, that was Tuesday, 2 days ago, is we looked at the performance issues that our original direction was leading towards. And I have a pretty clear idea of what I want to do with the library in terms of what will set it apart from other libraries. Specifically, this library will have real objects as opposed to the pseudo-objects. More details on the stream on Tuesday. But before I move ahead with this idea of having real objects, I want to see if the idea holds water. So I thought about an experiment that we could try, and that's what we're going to do today. That's what's on the menu today. We're going to try this experiment. And that will help us decide if we can go ahead with real objects or if we'll have to use pseudo-objects. The experiment goes like this. It's really simple. I'm going to implement the RBJ filters for a low-pass filter in the two different ways, with real objects using memory and with pseudo-objects. And then I'm going to stress both implementations by having like 100 filters of each. And then we'll see if the CPU use is stable. I know that using real objects will be slower. We determined this on Tuesday. But I want to see if it scales well. If it's consistently just a little bit slower or if it grows worse and worse as time goes on. And of course, a filter is not necessarily the best test for this because there are other operations that are even more expensive, like convolution and FFT. So maybe there are some other things we should test, but the filters are simple enough and we already have most of the implementation for them. So I'm going to test with filters. So that's what's on the menu. We are going to implement the RBJ filters, a low-pass filter. And we are going to use 100 of them on the two different styles of programming. And that may be actually a good exercise in how the different styles feel when you are programming. All right, so let's start this by creating a new effect that I'm going to call effect, real, because it's for real objects. And effect, oh, come on, no. Let's create another file. Effect pseudo JSFX. Bo is here. Hey, Bo. Great to have you here. How are you doing? All right, let's start with real objects, and then we are going to do pseudo objects, because this is the direction that I actually want to take in the library. And I'm going to borrow some of the implementation from this other file, but there is so much going on in this file that I guess it's easier for me to just copy and paste things over instead of trying to use the library. And Fotis and Stuff is here. Hey, Fotis and Stuff. Great to have you here. Alrighty. By the way, Fotis is, as I understand, a fan of Air Windows. And I learned something about Air Windows that you may not know, and it is kind of cool. So there's this synthesizer. Okay, the full story is, I had a strong case of gear acquisition syndrome, and I decided to just download and try out all the free plugins I could find. Great way to spend time, I think. And I found this little synthesizer. It's not actually little, it's huge. It seems to be very popular. It is open source, which is great because if interested, we can dive into the source and learn from it. But it's a VST, it's not JSFX. So it's a synthesizer. And this is what it looks like. It has the things you would expect from a synthesizer, like, I don't know, some envelopes and whatnot. All right, but it also has an effects chain. And in this effect chain, there are lots of effects like you would expect, like chorus and delay and reverb, but it also has lots of Air Windows plugins in here. And that's cool. I thought that was cool. What is even cooler is that there is this other effect comes with Surge when you install Surge, and it is just that effects chain, but it's standalone and it's not for the outputs of the synthesizer. It is for anything you want. You just run any audio through this, and one of the options is Air Windows, so you can switch from all the most popular plugins, probably not all of them, but maybe the most popular, maybe all plugins up to some point in time, I don't know. But in any case, it's a convenient way to just try out different plugins instead of having to install 100 plugins and then have your DAW load 100 plugins and then go through a list with 100 plugins. You can just find the algorithm you want and be happy. Thought you would like to know that if you didn't know it already. Alrighty. Let's see what you are all talking about. Hi, running out of Portuguese slang, so just hi. Great to have you here, Arya. The whole gang is here. Yes, hoarding free plugins is the healthiest form of gear acquisition syndrome. At least it's not expensive. But the reason why I wanted to do that, to tell you the truth, is first because I wanted to know what the space of free software looks like since I am developing free software. I thought I'd better know that. And there are some very good stuff there. There is also a lot of junk, but there is a lot of good stuff there. And now I know more about what people are doing in the free software space. Not only in terms of free as in free beer, but mainly free as in freedom. Because I want my effects to not only be free to use, but also be open source. That's what we're doing here. We are all about openness. And the idea is that we are going to do great stuff and then give it all away. Yeah, but it's still not really healthy. Okay, so Air Windows, just the greatest hits in Surge. Great. Oh, and thanks for the happy birthday. Okay, so Arya has a new single out. I didn't know that. Can you I don't think you can put a link in the chat, can you? But I can try to. Is it on YouTube? Or is it on your website? Where do I even find your new single? I don't think it's on your channel. So yeah, let me know how I can post it on the chat for everyone to make it simpler for everyone. James here. Hey, great to have you. Yeah, it was my birthday yesterday. And as a gift to myself, with all the... Oh, okay, it's on Bandcamp. So I can go to IDDQD Sound, your great-looking new website, and go to Bandcamp. Oh, the Bandcamp link is not here. So, see, you are making it hard for me. Is it under music? Well, I guess I can go through here to Bandcamp. There we go. I'm going to post the link here for everyone. And yeah, so as a gift to myself, I was saying, since I had all those free VSTs, I thought I would put together a track with all my recently installed free VSTs. So if you want to give it a listen, you can go listen to Arya's new single, or you can try this little guy here. It's over here on my channel. Oh, I didn't know that. Happy birthday, Bo. It seems like everyone's birthday is... Oh, yeah, thanks. I mean, it is the kind of thing that you listen to when you are at work. If you pay attention to the track, it is, I think, a bit repetitive, but that's actually kind of the point. When you are working, you want to get into the zone. So it's kind of this trance, this meditative state, not trance as in dance music, but just this meditative state where just the loop repeats a lot. But if you pay attention to it, it can be kind of annoying. Yeah. All right. Okay. So let's implement one of these guys. Let's implement one of these filters. Let's start with the real implementation, the one that I actually want to use if I can with real objects. So let me go and grab the part of the code from the library. And I think I can probably just copy and paste most of these. And I think I'm also gonna need the enumeration stuff in the beginning. And I think I'm also gonna need from the demonstration that was used in the library, the old version of the library that is probably gonna die, but is gonna be reborn anew starting today. But yeah, I'm just gonna have a low pass for this one. So I guess I wanna have something like this. I'm making this just so I can copy and paste and most things will probably work. And this, I'm copying all of this into the wrong location because the implementation as you left it on Tuesday was using pseudo-objects. It was the fastest. It reached 0% CPU on my machine. Oh, and it shouldn't be on the JFX block. It should be on the sample block because we are just processing the audio here to measure the performance. We are not interested in any kind of graphics. This plugin will not even have a slider. It's just really for testing. So where are we? Here, over there. And I don't need to check the page, just that. Okay, let's double check that everything in here makes sense. Are we even using error? Yes. And I could get rid of most of it. I think I should actually. Should get rid of everything that is not a low pass filter because I'm going to test with a low pass filter and checking which kind of filter may take time, and I'm not going to implement that on the real version, so better not do that. So let's check the place where we are verifying what kind of filter we are working with and just remove all the other kinds of filters by doing this. Alrighty, let's check all of these again. Well, I don't need to check if the thing is shelving or peaking because we didn't implement those. I, in fact, don't think I will do this error checking, so let's just remove that. And I'm gonna fix the indentation. Bam. Let's double check this again, one last time. I'm not only gonna have the Q, no, I guess I'm using the bandwidth because I was comparing with REAQ. So yeah, I was using bandwidth. So I'm gonna get rid of these two other versions. Oh, and now I'm not even using this, am I? Yeah, just simplifying a lot here. Yeah, I only have one kind of filter, one kind of bandwidth or width, so not gonna bother with the enumerations there. And with that, I don't think I'm using the enumeration anymore, except for error. But am I even doing error checking anymore? No, I removed everything that was doing error checking. So now we have just one method to configure the filter. We only have one single type, and we only have a single wideness value. So I'm going to rename everything that is called wideness value to band width. And dB gain I don't think is used because that is for slope. Yeah, so I will not need db gain. So I will not need big A. All of these I will need. Yeah, that looks right. Then for local variables, that also looks right. And then when I calculate the alpha, I only have the case where my width is determined by bandwidth. So I'm going to remove these checks. And then compute the coefficients and normalize them. And then to actually filter a sample, I will need to get a hold of the coefficients. The x and y no longer make sense because we are rolling out xn, xn minus 1, and so forth. And then finally, we do the computation over here. And I don't need that. To configure, now I don't need these 3 pieces of data. I just need the frequency and the bandwidth. And there we go. And now to actually test this, I think what I'm gonna do is I'm gonna make it mono. Just like that, yes. Let's try to see if this works, and then we'll stress this by having 100 of the filters. But I mean, look at this implementation. This is not bad. I kind of like the way that this reads. All right, so let's see if the pseudo thing is doing what we expect it to do. Oh, I'm gonna run some audio, some actual audio through this. So let me get rid of my outputs, mute, and put the slider down. I really want to make sure that I'm not outputting any audio. And then we are going to use another one of the free plugins I found. This is a really good one. It is like the linear analysis part of Plugin Doctor, but it is a VST, so I can use it in REAPER with JSFX. Great stuff. And then I'm going to find my own, and this is the pseudo. Oh, it's using the sine hyperbolic. That's bad. But I think that this is incorrect, isn't it? No, that's correct. So let's grab the implementation of the hyperbolic sine from here. There you go. And when I put this there, so it is filtering. I can see that the levels are going down, and we have a curve that is a low-pass filter. So our implementation is working. All right, let's implement the real, and then we are going to put 100 of these filters in a row, and we'll see what the performance looks like. But before that, let's see what people are saying. Yeah, I have a bunch of friends born around October 20th, so there is something in the air every year about February 20th. I know what you mean. Yeah. I'm checking the search page now. Can't find a download for the effects bank. I don't think that's how it works. You have to download the whole thing, and it's gonna come with 2 VSTs. I think it is like that. I don't know. I installed this using Homebrew on a Mac, but I think it may be separate plugins. Let's see. Yeah, it's a different plugin. So if you are on a Mac and you don't want to have the whole thing and you just want this guy, then I recommend this piece of software that I really like called Suspicious Package. This allows you to open a package in macOS, and you can just grab the parts that you care about. Like you can just grab one of the VSTs from the .pkg, and you don't have to clutter your machine with everything that comes with the PKG. It's good stuff. Yeah, all right. Okay. Yeah, I spent a lot of time looking at good free stuff. And the Burton, I think they are only free as in beer. I don't think the source code is available. All right. So let's implement this with real objects. I guess we can start with this because it's going to have the formulas and everything. And then how do you configure with a real object? Well, you're going to need to provide me the RBJ filter as the first argument. And I will not have local instance variables. I'll have local variables. Now, let's see. Oh, so maybe I will not have all of these variables. Like the normalized variables I may not need. Then all of these I think make sense. Yes. So these are the actual formulas. And then when I'm storing stuff, I'll have a quick enumeration here. LRBJ filter. And I'm just going to store the normalized coefficients. In the other implementation, I was storing all of these guys for debugging purposes. I was storing them in the data structure. I'm not going to do it this time. It doesn't really matter because the performance isn't affected by the use of memory. It's affected by the computations. It's affected by CPU. So that's fine. Oh, but that's not all. I also need the x's and y's on the data structure. So I'm going to put them here as well. And I think I start with xn. Okay. It is a good thing that the RBJ filters are easy to implement because it seems like I'm implementing them 10 times to find the best way to do it, I think. Okay, let's see if I have all the numbers right and didn't skip any. Okay, that looks good. Looks good to me. And then let's make sure that we are storing everything correctly. So in RBJ filter at LRBJ filter underscore underscore. So at this index in the data structure, can I store the corresponding values? That looks right. And then when I am actually filtering the results, I'm actually filtering a sample, I will need to get a hold of the RBJ filter as well as the sample, and I will not have instance variables. I will have local variables with these names. Let me just make sure that I have covered all the names of the local variables on this one as well. Seems like I did. And then on this one, it seems like we are good. All right, so let's extract stuff from the data structure. All of these guys are going to come from the data structure, maybe not. Let's start by extracting the coefficients, right? That's easy. So what we want to say is from the RBJ filter in that position. Oh no, don't do that. From the RBJ filter at that position, extract this variable. And then from these guys, I also want to extract them from RBJ filter at position RBJ filter underscore underscore, just like that. And then I actually do the computation. So I suppose that everything up to this point is a preamble. Then I actually do the computation, and then I need to store everything for the next round. So I will have lines that are going to set these guys. There we go. Now, to actually use the filter, we are going to do it like this. We'll have to configure it like this. And then to use the filter, it will be used like this. But we also need to allocate this filter. So let's do a quick memory allocation kind of thing here. Let me think. I think I'm going to just start with the one example of the filter. So I'll just have one of these. I guess that's what we are doing here on the pseudo version as well. Oh, we are calling it left. That's silly. Let's maybe call it 1. We'll have 100 of these. And let me just allocate this position in memory. It's just position 0, but never mind that. And then, I think that this implementation is about right. Do you see any mistakes? It seems like you don't see any mistakes. So let's try this. Let's disable this and, just bypass it. And then load in the real objects implementation of this. And it's also filtering, and it is right. All right. Not bad. First try. So next, let's put 100 of these in a row. And that's easier to do with the real objects. I mean, that's the point of having real objects. So let's have, I guess I'm going to commit what I have so I don't lose it. This is so cool, right? Awesome. So let's have 100 of these for the real objects. RBJ filters is equal to an array. So this array is going to have 100 positions. It's going to start in position 0. I guess I'm going to copy over the memory allocation kind of thing. Though, okay. I was thinking that could be a bad idea, but I don't think it's a bad idea. So let's just clean this up because I don't want necessarily to have all the ceremony that exists here. Yeah, I don't think I'm going to care about the initial value for this one. And I also am not going to do the error check. Not that it matters, but I'm simplifying everything else. So I'm going to simplify this as well. And then I just get a hold of the address, and then I return that address. All right. So RBJ filters is going to be a block of memory with 100 positions. And for index of -1, let's loop 100 times and increment this index. And let's go to RBJ filters at index is equal to, we need to allocate space for an RBJ filter. So let's create a function to do that for us. No, I was gonna have a local variable and everything, but I guess all I need is to store 11 positions. I need 11 items in memory to store these 11 fields. So now we have to RBJ filter new. Did I get this name right? Yes. So this is going to create 100 of these filters. And this is the reason why I want to have real objects, by the way, is so that I can write these kinds of loops. So now I don't need to do this. Oh, I do need to configure the RBJ filter. So maybe let's have a local variable called RBJ filter is equal to this. And then at the end, RBJ filter. And let's configure this filter just like that. Then when I am doing the sampling thing, I'm going to say that the sample starts with SPL 0, and I'm going to do a loop just like that. And I'm going to say that the sample is equal to filtering with this RBJ filter at this position. All right, so yeah, this is 100 filters in a row, and one filter is, I connected all the filters in series. So it is 100 low pass filters in series. That's what this is about. I guess this number 100 is kind of a magical number in this context. So I think what I'm going to do is I want to parameterize this. I want to be able to change this number and see if it affects performance, but I don't think I can have a slider for this because this affects memory allocation. So instead, I'm just going to have a constant here, like, I don't know, filters count. And then let's see what this looks like. We are working with the real one. Let's reload. Just make sure, yes, filters count is 0. That's weird. I guess just the block didn't run yet. All right, so yeah, you can see that because we have 100 low pass filters, the curve is different. It is kind of weird that it's cutting frequencies from below, but I guess I'll take it. And it is taking 3% of CPU. Let's see, yeah, 3.5. Yeah, I'm gonna say 3.5% CPU. So this guy takes 3.5% CPU. And you all in the chat, what do you think the performance of the pseudo object is going to be like? Do you think that the pseudo object is going to be faster or slower? Well, we know they're going to be faster, but how much faster? Do you think that having 100 filters with pseudo objects is going to be half the time, or half the CPU, or like a quarter of the CPU, or is it going to just stay at 0, not feel a thing about the number of filters? I wonder if I have some kind of bug here, because the cutoff frequency being different feels weird to me. Do I really have 11 fields? I don't know. I guess I will implement this with the pseudo objects and we'll see if the result is the same. But yeah, right. It is working. And with the pseudo objects, it's like at 0%. Right now. Let's implement 100 of these. So the cool thing is that I don't have to allocate this because they're going to be pseudo objects, but I think I'm going to write a little script to actually spit out all the lines, because this loop is something that I cannot do with pseudo objects. I will have to copy and paste this line over and over. Let's write a quick script that will go from, it is a list of 100 positions, and I'm gonna map, and I'm gonna join with new lines. And on this map, I will have a variable that I don't care about and an index. And what I want to spit out is a line that will look something like this. but I will have to replace this variable with index. Okay, that looks right. And then I'm going to console log this whole thing. And that's what I'm going to copy and paste. And this is something that you actually find in many effects in JSFX. And this kind of repetition like this. And I suppose that people use some kind of script just like the one I used. There are also some languages that compile to JSFX that do this. Then to filter, we are going to do something similar to what we did on the other one. We are going to have a sample, which is SPL0. And then at the end, we are going to have, we are going to set SPL0 and 1 to sample. And now we want to do a loop that is similar to that, but we are going to, instead of calling configure, we'll call filter. Okay. Oh, and I need to update sample when I do that. There we go. If you all know of a way of doing this kind of number series in Visual Studio Code, I would love to do that. Probably there is some kind of plugin, but I haven't checked. I know how to do rectangular cursors and I know how to do multiple cursors, but I wish there was a way for me to do just a series of numbers. That could be very helpful. All right, so let's run this and see if we get the same result. I'm going to reload the plugin. Yeah, it seems like the result is the same. But the CPU is not the same. Try and change the number of filters and see what happens. Okay, I will. But first, let's analyze the CPU, which is like, I guess, the main purpose of this. The CPU is different. It is faster to use pseudo-objects. I'm gonna say that this is, let's do the measurement again. So I'm gonna say that this is stable at 2.6, 2.7 right now. Yeah, let's say that this is stable at 2.7. And this is the real objects. So now this is stable at 2.7. I don't know why it changed, but it changed. So now it's at 2.7. Now it's even faster. All right, whatever. And this one, I'm going to say that this is stable at like 1.3. So it's about double. It's about double CPU. Let's compare these implementations. I'm going to commit what we have. And then we can talk about what we want to do with the library. And you all get to decide, along with me, what we are going to do. We'll decide together. So let's compare real objects with pseudo-objects. First, in terms of performance, I am going to say that pseudo-objects are about twice as fast. And I guess I could change the number of filters here and change the number of filters here, and we could look at some other measurements, but in general, I'm going to say that real objects are about twice as slow. When you are stressing this part of the ecosystem, right? When you are stressing this kind of looping thing. Now let's compare the code. how easy is it to use and to develop this library using real objects as opposed to pseudo objects? Remember, real objects is the thing that I'm proposing that is somewhat new. I don't think there is any other library that writes code in this style. And pseudo objects is the style that is most commonly used in JSFXs, are a lot more idiomatic. I think that the language is designed to use pseudo objects like this. So on the one hand, when I am using real objects, I have to do more memory management kind of things. So I have to have this enumeration to get some of the fields out of the real object, and I have to allocate memory, and everywhere where I want to store something, I have to do all these kind of extra lines, and these extra lines don't really exist here. Well, I guess it exists because I had to do the normalization, but if I just wanted to store these guys, then I would need some extra lines, or these lines would read like this. Instead of just reading like B0, it would read like this, which is not the best way of writing it. I guess it becomes even more evident here on this version, or this function. Because here I need to, in this case, I can just declare that these are instance variables on the pseudo objects, but on the real objects, I have to get a hold of all of them, and then I need to store all of them. And I think, I didn't measure this, and I'm not going to bother, but I think it is advantageous to have local variables, because if you use this variable in more than one place, then this would go to memory multiple times, and this would not. So in this case, I'm not using B0 multiple times, but I think it's still nice to fetch it out of the data structure and assign it to a local variable, because I will be writing this formula, and I want it to look as much as the formula in the cookbook as possible. So I like the idea of extracting the variables you're going to need, but then it is extra ceremony. While here, you could just say that these are instance variables. Here, you have to declare local variables, so this much is about the same. But then you have to be getting and setting all of these positions in memory, besides the stuff that you would actually have to do anyway, which is this much. So far, in terms of readability, I think I would prefer pseudo objects. So far. So on the implementation side of things, I guess this is a recurring theme. We talked about this last stream as well. From a library development perspective, having real objects is worse because we have to do more ceremony. But then check out this part of the code. Now, you can argue that this is relatively straightforward, and I would agree with you because it's a single line. But in most cases, it's not going to be a single line. It's going to be a block of code that needs to be repeated. It's inconvenient to have this much repetition in the code. I don't really like it. And the way that people cope with this in most cases is just they have a stereo plugin instead of having a multi-channel kind of plugin. So you would just instantiate RBJ filters for left and right. Or you would fix the number of filters you can have in your EQ, for instance. You can only have 8 bands or 16 bands because doing this kind of allocation or doing this kind of repetition in the code has this kind of limitation. Now, in this version, I need to be frank and admit that there is also a limitation. We are storing this in memory, so we need to allocate memory up front. And that limits the number of bands. But at least it's a loop. It's much simpler to write, much more compact. Now, simpler, I'm not going to say. It's less repetition. It may not be simpler because there are more concepts going on here. It's for a beginner, it may not be simpler to understand because there is looping, there is using memory, there is allocating memory, managing memory. But on the other hand, these kind of pseudo objects are kind of difficult to get your head around in the first place. So I don't know. Maybe it's a tie in terms of readability for the user. Well, one thing is for sure, people are going to find examples of code using pseudo objects a lot more often. So this is more foreign for beginners and experienced developers alike. And then we are doing here things on the sample block. And again, here we have repetition, which I guess is inconvenient, but kind of straightforward to get your head around. You look at these lines of code and you're like, oh, damn it, but you understand what they are doing. And then this is just a simple loop. So I guess that's the trade-off. Do you all want to go for something slower but more flexible? Or do you think we should go for performance? This is a false trade-off. Before you cast in your votes, there is a third way, which is to have a meta language that compiles to JSFX. That's the approach taken by some plugin developers. So instead of repeating code like this, you write maybe some JavaScript code. I guess that's the language that I would choose, and that's the language that Geraint, the developer of this other language that compiles to JSFX, he developed that in Node.js as well. So I would have some JavaScript that would generate a file, a text file, with this. So at this point, JSFX really become a compilation target as opposed to the language that you actually write stuff in primarily. But then I would have a loop that, well, I guess I can show you. It would amount to code that looks like this, right? I kind of generated this with JavaScript. So I would use JavaScript as a meta language in which to develop the plugin. And then in this case, we would have the best of both worlds in the sense that we would have a loop. We would not copy and paste code, but we would still have code that ends up looking like this. So it has all the performance benefits and the readability benefits. The downside is that now you're dealing with a meta language. There is more infrastructure, there's more stuff to learn, and you will have to keep your head straight in terms of what language are we in. When you put a back tick, you are going to JSFX land, and then when you use string interpolation, you're back into JavaScript. And in this case, we are just fetching a variable, but we could have some sort of loop, and then this whole thing would be inside another one of these template literal strings. So it can get confusing, especially for beginners, but it could be the best of both worlds. So as I'm going to open a new tab here with a new file with which is, so we have the real objects in JSFX, we had pseudo-objects written by hand and pseudo-objects generated with JavaScript, or a meta language. So now it's time to cast your votes. I guess this is about as much as I can tell you in terms of the trade-offs and everything. So what do you think? Which approach do you think I should take for my library? Let's see what you all have to say. I was thinking of the shape of the curve, not the CPU usage. Okay, yeah. But because I had the same result in both, I'm going to say that probably the code was right. And I think that the change in the shape of the curve was just because we were filtering more and more of the same. So, okay, I guess I can explain what I mean. So when we had just one filter, the slope started like about here, and then it went down. But because we have so many of them, even this small thing here that is the difference at this point, it compounded. So we had a bit of difference on one filter, a bit more on the second, and so forth until we had a lot of difference. And that's the shape that we see here. I think that explains it. So I'm okay with that. Let's also look at the face. Oh, the face is crazy. Oh, probably because the latency is incorrect. Well, but there is no latency. But increasing the latency is straightening things out, as I would expect. I would expect this curve to be not as crazy as the one we are seeing. And the latency only makes sense when talking about phase. Yes, that corresponds with my understanding of what phase looks like. So, oh, I'm using an FFT of order 12. What is 2 to the 12th? 4096. 4000. Is that a magical number? No, it's not. It still looks like crazy stuff. I think it's going to straighten out. I'm going to play around with this while you all think about the options we have and cast your votes if you want. Well, I guess the face is never going to get normal because of so many filters we have, right? No, but the face response should just add up. We should have a normal looking curve instead of this crazy stuff on the right. If I get the right latency. Yes, it is advancing to the right. Oh, it's getting better. It's getting better. Magical. Magical phase stuff. It's going to be like, oh, look at that. It's going to be like 124, the magical number. No. Gets worse again. We had a magical spot here around 1200. I mean, this much makes sense in terms of the response, but then everything else in this spectrum is so low in loudness. It is so low. It's like minus 500 dB or whatever, that all of this is just noise. The phase response doesn't really make sense because it's just the response of noise. Whatever. Do you have votes? Seems like pseudo-objects would be best and least confusing for people and for speed. So we have one vote for these, or maybe even that. I guess that makes sense. You know what? Here's what I'm going to do. I'm going to wrap this up. We're going to say goodbye now. Tomorrow, I'll be back here and we will decide on, well, we will have decided. You can comment on this stream, or you can send me emails, or you can reach me in whatever way you want and tell me your preference. And tomorrow we are going to restart the library, and we will use one of these three approaches. So to recap, real objects has never been done, is somewhat slower, a lot more flexible, stays in JSFX. Good stuff. Pseudo-objects, really fast, not as flexible, requires lots of repetitions. Pseudo-objects, about the same benefits in terms of speed, as well as in terms of flexibility, but more of a conceptual burden. That's the trade-off. So thanks, GemC, for your vote, and everyone else who's interested in this can vote as well. And tomorrow we'll get back here. We will restart the library. Even the design system and everything may change. I think it will change. In fact, I think I have some other ideas of how I want to structure that. I mean, the colors are going to be the same in the design system and everything, but the way I'm defining them, I think will be different in a few ways. So tomorrow we're going to restart the library, not from scratch, but we'll restart it following one of these three approaches. Meanwhile, thank you very much for being here. Thank you all for watching this and for helping me out with the development of this library. I hope that you are learning stuff and having fun. And I see you back here tomorrow. Goodbye.